Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on ring theory, lecture number 14, in which I will prove some theorems and solve some problems on skew field. Now we prove a theorem. Theorem is a ring R with binary operations, addition and multiplication is a skew field. If and only if each of equations a multiply x equal to b and y multiply a equal to b has a unique solution in R, where a, b are elements of skew field R, a not equal to 0. Now we prove this. Firstly, existence of solutions. Let R with binary composition, addition and multiplication is a skew field, and A, B are elements of skew field R such that A not equal to 0. Therefore, A is a non-zero element of the skew field R. Implies that A inverse exists. Now, A multiply A inverse B equal to A multiply A inverse multiply B by associative law, and this equal to identity element multiply B, and this equal to identity element multiply B equal to B. Implies that A multiply A inverse B equal to B. This is number 1. Therefore, A inverse B is a solution of equation Ax equal to B. This is number 2. Since in place of x, here we have written A inverse B and Ax equal to B. Now, B A inverse multiply A equal to B multiply A inverse A, associative law. This equal to B multiply A inverse A is identity element and this is B. Implies that B A inverse multiply A equal to B. This is number 3. Therefore, B A inverse is a solution of the equation Y A equal to B. This is number 4. Here we see that in place of Y we have B A inverse. Here Y multiply A equal to B. Now, uniqueness of the solution. If possible, let P be a solution of equation ax equal to b implies that ap equal to b. This is number 5. Since b equal to identity element multiply b and this equal to a inverse multiply b, a inverse equal to identity element and this equal to a multiply a inverse b, associative law. Since R is a skew field, so associative law holds. This is number 6. From 5 and 6, we get here in 5 b equal to ap and in 6 a multiply a inverse b equal to b. Therefore, ap equal to a multiply a inverse multiply b. By using cancellation law, p equal to a inverse b. By cancellation law, this is number 7. Therefore, we get that ax equal to b has a unique solution, a inverse b. Similarly, we may show that the equation y a equal to b has a unique solution, b a inverse. Now conversely, let R with binary operation addition and multiplication be a ring, A, B belong to R, A not equal to 0 and each of equations ax equal to b, ya equal to b has a unique solution. We have to show that R with binary composition, addition and multiplication is a skew field. Since R with binary composition addition is a ring, so we have to show that number 1, unity element in ring R. Number 2, each non-zero element is a unit. Let E be a solution of ax equal to a, implies that ae equal to a. This is number 8. Again, let E prime be a solution of ya equal to a implies that e prime multiply a equal to a. This is number 9. Let C be an arbitrary element of ring R and P be a solution of AX equal to C, implies that AP equal to C. Let this is number 10. Again, let Q be a solution of equation ya equal to C, implies that in place of y we write QA equal to C. This is 11. Now C multiply E equal to C means here QA multiply E, and this is equal to Q multiply A multiply E, associative law since ring, and A multiply E here is A, Q multiply A using 8, and Q multiply A is C, implies that C multiply E equal to C. This is number 12. Now E prime multiply C equal to E prime multiply C equal to AP, A multiply P, and this equal to E prime multiply A multiply P, associative, and E prime multiply A equal to A using 9. This is A multiply P using 9, and A multiply P equal to C using 10. Here Q multiply A equal to C, this is using 11. Let this is 13. Since C is an arbitrary element of ring R, therefore replacing C by E prime in 12, we get here in place of C we write E prime multiply E equal to C. C means E prime. Let this is number 14. Replacing C by E in 13, we get here in 13 left side is E prime multiply C. In place of C we write E. E prime multiply E. In place of C we write E. This is 15. From 14 and 15 we get here left side same, then right side will be equal. Therefore we get E prime equal to E. This is number 16. Therefore from 12 and 13 we get here C E equal to C E equal to C equal to, here in place of E prime we write E. E multiply C equal to C. Therefore E prime equal to E using 16. This is number 17. Since C is an arbitrary element of ring R, therefore from 17 we get that E be the unity element of R. Therefore this proves that R contains unity element. This is number 18. Now let R be a solution of equation AX equal to unity element. Implies that AR equal to unity element. This is number 19. Again, let S be a solution of equation Y A equal to identity element. Implies that S A equal to identity element, means unity element. This is number 20. Now S multiply A multiply R equal to S multiply A multiply R associative. Since A multiply R equal to unity element, implies that S multiply unity element. Here S multiply A equal to unity element using 19 and 20. Implies that S equal to R. This is number 21. Using 21 in 20 we get R multiply A equal to unity element. Here in place of S we write R. This is number 22. Therefore, from 19 and 22, we get A multiply R equal to R multiply A equal to unity element. Therefore, R be the multiplicative inverse of A, implies that A is a unit. Since A not equal to 0 and A is a unit, therefore each non-zero element of R is a unit. Therefore, we get R with binary operation addition and multiplication is a ring with unity, and each non-zero element is a unit. Therefore, R with binary operation addition and multiplication is a skew field. Proved. Now we prove the next theorem. Theorem is the set of all non-zero elements of a skew field form a group under multiplication. Now we prove this. Let S be a skew field and S star equal to S minus a set containing only zero element. And this is the collection of all non-zero elements of S. Means here we have not taken zero element. So non-zero elements of S, collection of all non-zero elements of S, S star is. Since it is obvious that S star is subset of S. Number 1. Let A, B belong to S star. All elements of S star will be non-zero element. A is a non-zero element, B is non-zero element, and A, B belong to S, since S star be the subset of S. Each element of S star will be an element of S. Implies that A multiply B belongs to S, since S is a skew field. So it is a semi-group, that is closure property holds of S. This is number 3. Since a skew field contains no divisor of 0, therefore A not equal to 0, B not equal to 0 implies that A multiply B not equal to 0. This is number 4. Therefore, A multiply B is a non-zero element of S, implies that A multiply B belongs to S star, because S star contains all non-zero elements of S. Hence, we get A, B belong to S star implies that A multiply B belongs to S star. Therefore, closure property holds. Number 2. Let A, B, C belong to S star and S star is subset of S, implies that A, B, C belong to S and S is associative. Since S is associative, therefore A multiply B multiply C equal to A multiply B multiply C. Therefore, S star is associative. Number 3. Since unity element E belongs to S skew field and E not equal to 0 implies that E belongs to S star. Therefore, S star contains unity element. Number 4. Let A belongs to S star implies that A not equal to 0 and S star is subset of S, implies that A is a non-zero element of S, implies that A is a unit, implies that A inverse exists in S. Since A not equal to 0 implies that A inverse not equal to 0, implies that A inverse belongs to S star. That is, A multiply A inverse equal to A inverse multiply A equal to unity element. Therefore, each element of S star has multiplicative inverse. This is number 5. This is number 6. This is number 7. And this is number 8. Therefore, from 5, 6, 7 and 8, we get that R star with binary operation multiplication is a group. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.